Hello, this is Oliver Rossi, and this is my presentation on what is causing beach erosion on Cape Cod. My research question: what causes beach erosion on Cape Cod, and how do storms, sea level rise, and human development each contribute? Why this matters for the Cape. Cape Cod loses shoreline faster than almost anywhere else on the East Coast because it is built from loose glacial sand instead of solid bedrock. This presentation covers three forces working together: storms, sea level rise, and human development, and how each one changes the coastline in a different way. Local angle: erosion is not the same everywhere on the Cape. Comparing specific towns shows how the same three causes can make one beach grow while another disappears. Geologic background: why Cape Cod erodes so easily. Glaciers built the Cape. About 15,000 to 23,000 years ago, huge glaciers covered this area. As they melted and moved away, they left behind piles of sand, gravel, and rocks that eventually became Cape Cod. Not solid rock. Unlike the granite coast of Maine, Cape Cod is made of loose sand, gravel, and clay. Waves can carry this material away much more easily than solid rock. In the words of geologist Robert O'Dale, who spent decades studying the Cape for the U.S. Geological Survey, put it simply: sand is the very lifeblood of Cape Cod. It rebuilds, too. Because the Cape is loose sand, it does not just erode, it also rebuilds in other spots. Sand lost from one beach often shows up again miles away. Erosion here is a natural process, not only a disaster. Cause number one: storms. Storms speed up erosion. How it works: nor'easters and hurricanes create powerful waves that hit the coast at an angle. This pushes sand sideways down the coast in a strong current and carries it away fast. Speed of change: one major storm can remove months' worth of sand in just one day. Along the Nauset to Monomoy beach system, storms can cause the shoreline to shift 3 to 20 feet in a single year. In 1996 in Truro, a sudden landslide near Highland Lighthouse struck with almost no warning, a reminder that storm erosion does not always happen slowly. In 1987 at Nauset Beach, a powerful storm broke through, and it carved a brand new inlet between the ocean and Pleasant Bay. That one event reshaped the harbor and is still affecting the coastline today. Sea level rise. Rising seas are eating the shoreline. The rate: sea level in Massachusetts has risen about 1 foot over the past century, and the Woods Hole Oceanographic Institution says that the rate has roughly tripled in recent decades. The math: the Cape Cod Commission estimates that about 100 feet of shoreline retreat for every 1 foot of sea level rise on a sandy beach, which could mean losing 400 to 1,000 feet of shoreline by the year 2100. For about 15,000 years, George's Bank, a shallow underwater area southeast of Cape Cod, helped reduce the strength of some Atlantic waves before they reached the coast. As sea levels rise, deeper water allows more wave energy to pass over George's Bank, which can increase erosion along parts of Cape Cod's south facing shoreline. The long view: NASA and USGS researchers think that the sea could fully reclaim Cape Cod in about 5,000 to 6,000 years. It is a natural process that will likely keep going no matter what people build to stop it. Number three: human development. How it works. Seawalls, jetties, and groins are all man made structures meant to protect specific properties, but they block longshore drift, the natural flow of sand down the coast. Once that supply is cut off, beaches farther down the coast receive less sand. Sandwich. Jetties built to protect the entrance of the Cape Cod Canal have damaged Town Neck Beach. Barnstable. Jetties meant to keep a channel open near Sampson's Islands caused erosion and habitat loss. Fixing it took about a decade and $2.8 million. By the numbers: a jetty at Sandwich Harbor caused up to 361 feet of shoreline erosion across a 5,600-foot stretch of coastline. The jetty blocked the natural movement of sand, leaving less sand available to replenish beaches farther down the coast. Local relationship: how erosion affects Cape Cod towns. Billingsgate Island off of Wellfleet, a 60-acre island that was once home to a fishing village, about 30 houses, and a lighthouse, slowly disappeared as storms and rising water wore it away until it was gone by 1915. Nauset Light in Eastham, physically moved inland in the 1990s after decades of cliff erosion brought the ocean nearly to its foundation. Growing versus shrinking. Harwich on the Cape Cod Bay side is gaining about 1.3 feet of shoreline a year, while the south shore of Martha's Vineyard, including West Tisbury and Chilmark, are losing more than 2 feet a year. These areas are all part of the same island chain. Why the difference? Geologists believe sand from the southern beaches slowly moves north and helps build up Provincetown. Because of this, Cape Cod is slowly rotating clockwise about half a degree every 1,000 years. Key Earth science concepts: weathering and erosion. Waves, wind, and storms break down and wear away the coastline over time. These natural processes are responsible for much of Cape Cod's changing shoreline. Sediment transport. Waves and ocean currents move the sand and other sediment along the coast. This process shapes beaches and explains why some areas gain sand while others lose it. Relative sea level rise. This adds two things together: the global rise in ocean water from melting ice, plus land subsidence, meaning the ground itself is slowly sinking. Both raise how much water reaches the shore. Deposition. As waves and currents slow down, they drop the sand they were carrying. Over time, this builds beaches, sandbars, and other coastal features while constantly changing the shape of the shoreline. Here's my personal evidence. I went to Nauset Light Beach in Eastham, and in these first two pictures, you can see some erosion control structures. In the first one, you see fencing at the overlook. Wooden fencing marks the edge of the parking area above the bluff. In other words, a steep sandy cliff along the coastline, keeping visitors off the fragile, actively eroding dune. In the second picture here, we see sand fencing, dune grass, and a warning sign. Planted beach grass and a low wooden fencing trap blowing sand and slow erosion to the best of its ability, while a posted warning sign warns people to stay off the dunes as there is a high risk of danger. Here's some more of my personal evidence: signs of active erosion at Nauset Light. In this first picture I took, you can see exposed roots at the beach level. Dead trees and roots hang over the open air where the bluff has eroded out from underneath them, a clear sign of active erosion. In the second picture, you see the full bluff face. A wider view of the same bluff shows the scale of the cliff, with roots and dead branches exposed along a long stretch of sand. And in the third picture, this photo was taken from the top of the bluff, looking out over the Atlantic Ocean. At the end of the bluff, the land drops off steeply into the beach below, showing the dramatic change in elevation along this part of the coastline. In conclusion, so what's causing beach erosion on Cape Cod? My research shows it's storms, sea level rise, and human development all working together. It's a natural process that has been reshaping this coastline for thousands of years, and it is not going to stop. Thank you for watching. Here's my works cited, and here's my works cited with the images I used on my slides.